Hey guys, welcome to my video today. In this video I'll be talking about properties of exponents and using those properties of exponents to simplify some expressions. I'm going to give you about 3 expressions, and then just know that you can keep using these properties to do all kinds of them, but really you don't want to use too many when you have a plus or a minus in between terms, and I'll show you what that means in just a second here. But here are the properties that you really want to make sure that you know. So let's say a to the n. A is going to be a constant, so a is a real number, and a to the n times a to the m is equal to a to the n plus m. So if we have two things with the same base, different exponents, and we multiply them together, we can add those exponents. If we have the same base but different exponents and we divide, then we can subtract those exponents. Coming out of this, a to the 1 is just going to give us a. So anything raised to the 1 power is just itself. Anything raised to the 0 power is going to be 1. A to the n raised to the m. So if I raise a power to a power, I'm going to multiply the powers. Then if I have a fraction and my power is in the denominator, that's going to be, you can move it up as a negative power, so a to the negative n. And finally, the root of a number, so the nth root can be written as a fractional power, 1 over n. Okay, so we're going to use all of these. And I'll show you where we're going to use this one here, but we'll use all of them in a couple of examples. Okay, so let me see if I can shrink this a bit. Oop, 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 oop. That's not what I want to do. Let's try this again. Wow, did that not work or what? Okay, so we're just going to have to keep them at this size. I was going to try to make them smaller so that we can see here, but let's see our first example. We've got x squared y cubed over x to the 4th y squared, and we're going to raise that to the 2nd power. Alright, so the first thing we want to do is we can do a couple things here. We can simplify the inside parentheses, or we can distribute the 2 to every power. I'm going to go ahead and simplify the inside first and then distribute. So x squared over x to the 4th, okay, that's going to simplify. And we're going to subtract the powers. Now what I normally do is that the power that's higher wins on whether or not it's going to be on the top or the bottom. So since x to the 4th is in the denominator, my overall answer is going to stay in the denominator. So I'm going to go 4 minus 2, and my x squared is going to be down here. And 3 minus 2 is 1, so I'm going to have y up here, all squared. Then I'm going to multiply the 2 times the power. So I'm going to have y squared over x to the 4th. Okay, and this is my answer. Now, what I was talking about a second ago about whether or not you can use these with a plus or minus, if I add x squared plus y cubed raised to the power of 2, this is not y x to the 4th y plus y to the 6th. I cannot distribute this 2 if there's a plus right there. So don't do this. Don't distribute the power if you have a plus or minus inside. Notice these are all multiplied together, so I can distribute the power. Okay? But if you have a plus, you cannot do that. Alright. Let's look at another example. Let's look at something a little bit more difficult. 4x squared y times 3x y cubed all over x to the 4th y all squared. Okay, the first thing we're going to do is we're going to multiply the stuff on the top here. Okay, so we're going to go 4 times 3 is 12. Okay, so 4 times 3 is 12. Pick a different color here. Let's go blue. And then we're going to do x squared times x, which is x cubed, because there's a 1 right here, so we're going to add the exponents. So 1 right here, y to the 4th, over, and now here, let's go ahead and distribute that 2 in here. So x to the 8, y squared. And now that we're here, we're going to subtract these here, the powers. So we're going to have x to the 5th on the bottom, because we're going to go 8 minus 3 and keep the x on the bottom. Here the 4 is bigger than the 2, so we're going to go 4 minus 2, which is y squared. And there we got our answer. All right? So let's try another one here. Okay. Here's another example. It's my last example for this video. We're going to have the cube root of x to the 4th, y, times x squared and y. Okay. So for this one here, I like purple. Purple's fun. Let's go with purple. So this one, we're going to take our third root here, and we're gonna put that to a power of 1/3. So remember here, I talked about that our rule here was that the nth root can be written as a fractional power. Okay, so we're going to go x to the 4th y raised to the 1/3 times x squared y. And we're going to distribute this 1/3 into our parentheses. Remember, there's no plus here, so I can do that. So we got x to the 4/3 y to the 1/3 times x squared y. So now what we're going to do here is we are going to add the powers, because see, we got everything multiplied together, so we're going to add 4/3 plus 2. To make that a little easier, I'm going to make that 6/3, right? Because to get a fraction, a common denominator, so I'm going to get x to the 4 and 10, that's 10/3. Y to the, let's see, y is going to be, this is 3/3, right? Because it's a 1. So I need a common denominator. So it's going to be 4/3. I think what I'd like to do here is to simplify this a little bit more. I'll make this x to the, I think the easiest thing to do here is to make this a mixed number. So that's 3 and 1/3. And y is 1 and 1/3. Okay, and then I'm gonna make this x cubed times x to the 1/3. Okay, so I don't lose you here. Let me show you what I did. That way you can see how I separated this. Okay, 3 and 1/3 is really 3 plus 1/3. So I separated this to x cubed times x to the 1/3, because if I put these together, I'll get this here. If I put these together, I'll get this here. Now the reason I did that was because now I can put x cubed y, and since both of these have a 1/3 power, I can put them into a cube root of x and y. Okay, and this is how I want to leave my answer. Alright, so x cubed y, cube root of xy. This would be simplified. Alright? Okay, so I want to give you a couple practice problems. Okay, let me get my black back here. Alright. This color already exists for this tool. Okay. Well, that's talking about. Let's go practice. Okay, so here are the practice problems. Your practice problems are, number 1, and simplify each of these, okay? Simplify, that's all these were simplifying. Simplify 4x cubed y squared over 3x y to the fourth. Okay, that's number one. And number two, simplify the square root of x to the fifth y times x cubed y to the fourth. Okay, so go ahead and simplify those. You might want to pause the video right now because I'm going to just give you the answers. So thanks for joining me if you leave now. Okay, here's the answers to these. I forgot to square, I forgot to square this. I really wanted to be that squared. Let's go ahead and simplify this since I forgot to put the square there. But if I had the square there, I would throw it in. But let's go ahead and simplify this. Simplifying this, we would just subtract those. So x squared over 3, and subtract these, y squared. All right, let's do this one now. And we have, give me some more room here. We're going to change the first one into 1/2. And then change that to x to the 5 halves, y to the 1/2. Okay, so I'm going to get 3 is going to be 6 halves again. 6 halves, 6 halves is going to be 11 halves. And then 8 halves will give me 9 halves. Okay, which give me x times x to the 5th times x to the 1/2 times y to the 4th times y to the 1/2. Okay, again I made this 5.5 and I made this 4.5, and then I'm going to have x to the 5th, y to the 4th times the square root of xy. And that's my answer. Okay, thanks for joining me. Hope this helped. If you have any questions or comments, put it in the comments section. Thanks.